everyone, myself Nishitha, Assistant Professor, Department of CSIT, working at MLR Institute of Technology. In previous sessions, we have seen about disk attachments, what are different types of disk attachments, what are they, network attached system, storage attached system and host attached system. So in this session, we are going to see about disk scheduling algorithms. So let us see the overview of this presentation. So in this presentation, we are going to see about disk scheduling algorithms. There are 6 different types of disk scheduling algorithms. Let us start with first one. So what do you mean by disk scheduling algorithm? So disk scheduling is a technique operating systems used to manage the order in which disk input-output requests are processed. So, whatever the operations done with the input and output that are attached through this disk, and the technique used by the operating system to manage the order of input-output requests and how they are getting processed. Disk scheduling is also known as input-output scheduling. So it is also known as input-output scheduling. So what is the goal of this disk scheduling algorithm means? The main goals of this disk scheduling are to optimize the performance of disk operations. So it is used to perform some disk operations. So how we are going to manage the disk scheduling and how we are going to perform each disk operation and how we are going to schedule according to the disks. So disk arm will be placed and that optimal that can be reached some operations and that can be perform some disk operations. So what are the different types of operations performed by this disk? Reduce the time it takes to access data and improves overall the system's efficiency. So it reduces some time and it is used to access some data, and whatever the operations performed and the efficiency of the system will be overall decreases or increases. So based on the operations performed, either it may increase or decrease, but the efficiency of the system will be always increases. So why? Because the main goal of this disk scheduling is nothing but to perform some disk operations. So that operations can be performed by reducing the time and it can access the data. Overall, it improves its system's efficiency. That is what about how these goals performed by disk scheduling algorithms. So let us see what are the different types of disk scheduling algorithms. So there are different types of disk scheduling algorithms. Here, disk scheduling algorithms are crucial in managing how the data is read and from the written to computer's hard disk. So how the data is read. So whenever the user want to access some disk scheduling algorithms, there is a crucial in managing the data. So that is what how you are going to read the data and how you are written in to a computer's hard disk. So how we are going to return to a computer's hard disk. That is what how we are going to perform this disk scheduling algorithms. So these algorithms help determine the order in which disk read and write requests are processed. So these algorithms help to determine the order in which the disk can read and write the request and that are processed significantly, impacting the speed and efficiency of data access. So whatever you are performing that algorithm, that can be required to order its read and write requests that are processed, and they are significantly impacting the speed and efficiency how to access the data. So whatever you are performing, that can be read and write requests can be processed and they are significantly impacting its speed and efficiency for the data access. So there are different types of disk scheduling algorithms. What are they? Let us see. So common disk scheduling algorithms include 6 types. What are the 6 types of disk scheduling algorithms means? First one is first come first serve, nothing but FCFS. Next one is shortest seek time first, means SSTF. Next is scan, then C scan is nothing but circular scan, and look and C look. C look is again circular look. So these are the 6 different types of disk scheduling algorithms. We are going to discuss one by one with an example problem. So let us start what are the key terms of this disk scheduling algorithms and how we are going to calculate the seek time and what do you mean by latency and rotational latency. Let us see. So there are different key terms associated with disk scheduling algorithms. For first one is seek time and second one is rotational latency and third one is transfer time and fourth one is disk access time. These are the key terms which we are going to access the disk scheduling. You need to calculate some seek time, rotational latency and how we are transferring each disk and how we are going to calculate the disk access time. So let us start our first key term with seek time. So seek time is the time taken to locate the disk arm to a specified track where the data is to be read or written. So here the seek time is using to calculate the disk arm to a specified track where the data is to be read and write. So the disk scheduling algorithm that gives a minimum average of seek time is better. So in this you are calculating the disk arm with a specified track where the read and write operation have to be done, and so the disk scheduling algorithms give some minimum average of seek time, then better. This is how we are going to calculate the seek time. You will be clearly understand while we are doing the problem. So next, what do you mean by rotational latency? Rotational latency is the time taken by the desired sector of the disk to rotate into a position so that it can access the read-write heads. So this rotational latency is time taken by the desired sector. So whatever the sector is present, that will be taken as one rotational, and the time taken is desired sector of disk each rotation into a position, and so that it can access the read-write heads. So here it can access both read-write heads. So the disk scheduling algorithm that gives minimum rotational latency, then better. So here the disk scheduling algorithm gives us minimum rotational latency than seek time. It is better than seek time. Next, transfer time. How we are going to transfer each disk time? Transfer time is the time to transfer the data. It depends on the rotating speed of the disk and the number of bytes to be transferred. So transferring the data one by one, and it depends on the rotation of each speed of the disk. Why? Because each speed of the disk of the data, how we are going to transfer, means one rotation of the disk can be traveled with only one speed. For one rotation, how much time or how much speed the rotation is completing. How we are transferring the data by one rotation. Can you calculate it by easily accessing this transfer time? So we are using some formulas how we are going to calculate this. So next one is disk access time. Disk access time equals to seek time plus rotational latency plus transfer time. So this is the disk you are going to access. So disk access time. To calculate this disk access time, we need seek time and next rotational latency plus transfer time. How we are going to transfer? By these three calculations, you are going to calculate the disk access time. What is the disk access time? Equals to seek time plus rotational latency plus transfer time. So how we are going to calculate total seek time? Total seek time equals to total head movement into seek time. So we are going to calculate with the total head movement of the disk into seek time. So seek time means how the location of disk arm is specified to that track where the data is read and write. So next, how we are going to get the disk response time. So response time is the average time spent by a request waiting to perform its input-output operation. Here, the disk, how we are going to get the response from the disk time when the rotation or seek time is completed. At what time did you got the response from the disk arm? So you need to calculate by response time is the average time spent by a request waiting to perform its input-output operation. So based on the input-output operation, how much the requesting waiting time is performed, you need to calculate its average. The average response time is the response of all the time requesters. So the average response time is the response that the time taken from the all the requesters. Variance response time is the measure of how individual requesters are serviced with respect to average response time. So here various response times we are getting from various disks. So to measure each of the individual requesters are serviced with respect to average response time. So whatever we are performing the disk operation or disk, when it's completing its individual disk and the request is performed individually and we are serviced through with their average response time. So how much time they are under waiting condition, at what time our disk has been responded. So we need to calculate based on this average response time. So the disk scheduling algorithm that gives minimum variance response time is better. So the disk which is giving the minimum of response time, then it is calculated than others. So it is better. So here we are performing some disk LEC, seek time, rotational latency and transfer time. So what is disk access time? Disk access time is nothing but seek time plus rotational latency plus transfer time. So this is how we are going to calculate about disk access time. So then how we are going to calculate this total disk response time means disk queuing delay plus seek time plus rotational latency plus transfer time. So all this you are going to calculate on based on the disk responses. So this is how we are going to calculate the disk access time and disk response time. So in this session we have seen about disk scheduling algorithms. So what are the 6 different types of disk scheduling algorithms means FCFS, SSTF, shortest seek time first, then scan, then C-scan, then look, then C-look. So we have seen these 6 types. We are going to discuss one by one. So next we need to calculate the seek time key concepts, rotational latency, and disk access time. Disk access time is nothing but all the 3: seek time plus rotational latency plus transfer time. This is how we are going to calculate about the disk access time. So if you have any doubts, you can comment in comment box. Thank you.